Yeah, I will talk about fintech use cases of AI. Before that, I did a PhD in health tech and skin cancer recognition. But I'm leading the company called Codete, where some of the customers are fintech customers. And obviously, I cannot say everything, right? It's a presentation based on from our experience working with fintech companies. But I try to say as much as possible, not breaking the contracts at the same time. Which one? This one. Okay. Yeah. So when it comes to fintech and AI, it can be combined and used in many cases. Here's the list of the cases. Obviously, security. There are some classic cases like the fraud detection, for example. It's obviously used for the analysis, stock market prediction. It can be used also for blockchain. And obviously, risk management, insurance prediction. It's kind of analysis as well. At least these are the topics that we have experience with. Probably all of you know Kaggle, right? Have you checked how many competitions are actually related to fintech? There are 20 currently that are finished. Some of the competitions here, some of the companies that actually started the competition are also our customers. Don't worry, I will share the presentation later. You don't need to take a photo, don't worry. It will be on our blog. There are a few that are really interesting. I mean, all of them are interesting, but some that are especially interesting for me. And one of that is a sentiment analysis for stock prediction. I will talk about it later in more details. But as you see, also InsurTech, Prudential, AXA, for example, and there are even more. There are some hedge funds here on the list that are also, as you can see here on the list, it's not always about classification, about developing a model that will at the end give accuracy like, I don't know, 90%, 95% or whatever. Sometimes the challenges are more about, for example, denoising the data, reducing the dimensionality. So it's not always the case that we need to build a classifier. Yeah, more or less. And here's again the first one from Santander customer satisfaction competition. It's also about sentiment analysis. So the first topic is the security that I mentioned in the first slide. You know what's that, right? I don't need to explain. There's a convolution network used very widely in many cases. So now it's I'm actually traveling on many conferences. Some of them are actually related to fintech, and it looks that there are more and more companies actually using actually face detection, face recognition for security for banking. Obviously, banking case is a bit more complex because they are highly regulated, so there's a bigger issue with that. But I think at some point it will be applied widely. Sentiment analysis, it's about getting to know what's the emotion behind the text, for example, or the voice as well. And we have built a library that is open source. You can actually find it here. Here's the link, and the link for GitHub is on the next slide, where we have built a library that we compared with Core NLP. That is a commonly used library, and it is our library gives better results for most of the data sets that we have tested. So this is one thing that we have developed also for our customers. Obviously, for each customer, it's a specific case. This one is our library that we have shared on open source. I don't have too much time actually to explain all of the topics related to sentiment analysis. So if you're interested, you can also go to a live training on the O'Reilly platform, where I'm giving also a training in Python how to actually build our sentiment analysis method from scratch. Yeah. More or less, how does it work? How the sentiment analysis method works, or our method, how does it work? It's combined about 1, 2, 3, 4, 5, 6 steps, more or less. The most important thing, and it's not only related to sentiment analysis, it's not really the random forest or any other classification method. It's about the data. So when we are training, showing how to build a sentiment analysis library, we are actually mostly focusing on cleaning the data to get the good data that we can actually analyze. And obviously, now splitting the data using some NLP methods, reducing the dimensionality, using some classification method, like in this case random forest, and get the results. If you step by our booth, you can see this library used on tweets live. So it is working. And here's the code here on the bottom. You can just go there, download it, and test it. The next topic is actually blockchain and IoT. I combine it together because we are doing both, but because of the contract agreements, I cannot say too much. What I can say about blockchain is that if you go and Google it, blockchain AI, in most cases you will find that some people will say that they are trying to combine AI with blockchain in using AI in a more distributed way. We don't have such an experience, really. What we do, we are using more like AI like a part of the process before the blockchain itself is used. So it's a bit different. For now, I cannot say exactly which customer it is, what exactly it is. It's combined with, obviously, with the coins, and probably next year I will be able to say more about that. And when it comes to IoT, this is a known topic, IoT, InsurTech, cars, the devices that will actually measure how you're driving, and based on that, predicting the insurance price. The other big topic in fintech, it's about chatbots. It's replacing the customer service, right? This is one of the examples. Or measuring the sentiment of the social medias. This is also another example. We have three generations of chatbots. It's a rule-based, retrieval-based, and generative-based. In the first case, there were before some other speeches only dedicated to chatbots. But just to go fast through, rule-based is when you have two lists, question, answer, getting the question, replying with the answer. So quite easy. No AI, no machine learning used. Retrieval-based, when you actually learn, you have a neural network behind usually, and we have the data set, and we are generating the answer based on the data set. And generative-based, when we use, for example, autoencoders, so deep learning methods, or GANs, where we are generating the answer that was not known before. It's totally generated with a full, it's properly from the grammar point of view and the language point of view, but it's totally new. And again, here is a workshop on GitHub. It's a Jupyter notebook you can download and check it out. And the first link, obviously, we are also having a training on Safari online. Then you can actually learn how to build each of kind of these bots. Unfortunately, I don't have enough time. PSD2, also a known topic, and when it comes to fintech, we have built some time ago, before actually the PSD2 topic appeared to be a topic. We have developed a library, you can download here, which is used to predict the user's behavior. It means that on the server side, you are predicting what will be the next step of the user using an API, and we are sending the data, predicting what's actually the next step in one request, one response instead of many. So we are reducing the number of requests, which is at the end faster for the user. And here's also a document how it actually is working. Another topic that is quite important. There are some legacy models. We spoke with some of our customers, especially the big companies. They have a problem with I could say issue, it's a better word here, that they have built some models 3 years ago, 5 years ago, and now they're using a totally different framework, different library. Let's imagine we are going 2 years back. If I ask you what library for machine learning are you using? Probably the answer would be Tiano, right? Now, if I ask the same question, you will say probably Keras or PyTorch, right? What will be the answer in 2 years? For sure not the same as today. There will be new frameworks, new libraries. That's for sure. We know that will happen, right? And if we go back 5 years, probably some of the companies used, I don't know, C++ or maybe R to build the models. And that's a problem in the meaning that if you have some legacy models that you still can use because it's working, but would like to actually move it to a new library or new language. It's kind of a tricky because you need to spend some time just to rewrite it to the new language, new framework. And we have actually a solution. We have built a solution that actually is solving this problem. It's a converter between the libraries and frameworks. If I can just ask you to show the demo. It's a just really short demo here. As you see, there's a converter. I know it doesn't have any UI because it's a backend converter. I mean, it's a backend, so you can see it here or on the tallies here on the side. And as you see, we are now converting from TensorFlow to Keras, from Keras to TensorFlow. The next will be from TensorFlow to Keras. We have also a converter from R, from some libraries from R to Keras and so on. So it's quite a hard thing because we have around. As you see, it's Dockerized. Now it's converting. You see the code here that is generating. Now, when you go through and do the analysis, how many libraries we have in machine learning, there are around 100. About 30 of them are used in production. And what we have built a converter between all of these, well, not all, but most popular libraries and frameworks. You have here the next one. You can see that actually the results are exactly the same for different data sets. So it's converting and giving the same results, which is good. If you know Apple, they have Core ML, right? They are importing from different libraries. They have such a solution. Microsoft now also has started our open source project where actually they are building something similar, and we do the same. I mean, not the same. We are doing something similar. We are building our own converter for everyone actually, because finally we would like publish this as open source as well. So as you see, here's the model build based on the previous one. And next we will have the results here. One of our customer that is actually in the automotive is something wrong. Is an automotive has the problem. Some other of our customers has the same issue, but it's also only related to the big companies that actually are working on machine learning for many years. Here are the results, and you will have for different models for different data sets, and it's the same. Okay, I have a few more minutes. So there is also one more thing that I don't have on slides. We see also one thing when it comes to fintech, especially. Obviously, this problem is also related to fintech. It's all to all different branches. More and more companies are actually establishing cooperation with universities, something that especially the fintech. One of our customer did a research that 2 of 10 research papers from the best journals in data science and artificial intelligence can be commercialized. So if you are a student, I would like to do some side projects in machine learning, just let me know and find my booth number 3. Maybe we can help you to get more experience in this area. That's it for now. 15 minutes, perfect. If you have any questions, feel free to ask.
Microphone, if you like. So.
Here it is. Yeah.
Where was it?
I like questions.
So on one of your slides, you showed term frequency inverse document frequency. I forgot what that was, classification or something, and you had also PCA. Forgot which.
You mean the sentiment analysis process?
Exactly.
Yes.
So my question is how important is the PCA part in that algorithm?
It depends on the problem and on data sets. Obviously, it's good to have it because if you can reduce the dimensionality with having the same result, then it's good. But you're right. It's not. It's not that we need to always use it.
I'm asking because you're using random forest after that, so I assume that random forest could just deal with I don't know how many features you had in that model, but if you had even like 1,000, you could deal.
That's true. It's random forest is one of the examples. Obviously, you can put a different classifier here, different method here as well. So that's why we have the whole process. But obviously, we can replace the classifier with a different one.
One more question.
Maybe following up on that question in terms of the classifiers, you showed the bag of words approach with the TF-IDF and then the PCA. What's your experience based on that using, for example, support vector machines, random forest, or naive Bayes?
Comparing to...
You showed random forest in comparison to other methods. What's your recommendation, like overall?
For sentiment analysis. We use for sure we use some probability method as well. SVM, I think it's good for pattern recognition. Maybe not really for this case, but it depends on the problem. And I think the classifier, obviously you can get better or worse results, but it depends on the problem. I would say it's hard to say. Some of the examples actually you can say, oh, SVM is the better one here. In this case, it's random forest. We put random forest because we get better results with this classifier compared to core NLP. But for a different example, you probably will get better results with different classifier.
That's it.
Okay, so if you have any more questions, I'm somewhere around here trying to answer all of your questions. Thank you.